Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. In the last episode, what we did was we did our debug drawing facility, so we can now draw lines and stuff. In this episode, what we're going to be doing is drawing our grid and snapping items to this grid. So this is going to be the first step that actually makes our level editor feel like a level editor where you can drag and drop things and you can have them snapping to the 2D grid of your choice. I'm going to go over some of the mathematics that helps us make this work and then describe exactly what's happening, and then we're going to go ahead and implement it. So let's get started. So drawing this grid is actually pretty simple. It's a mathematical formula that we can use to actually calculate any grid. Assume that this top left corner is 0, 0, and assume each grid has a width of x and a height of y. I'm doing this with variables because it will be important later on if we ever want to change the grid size. Now, the first thing we want to be able to do is if we have a point in the world, we want to be able to snap this to one of these corners. Reason being, when we're dragging around an object, we want to be able to have the mouse be here, but we snap it to one of these corners so that we know that the object is within this square. Well, how do we do that? Say this point is at some coordinate 133 by 67, okay? Now we can already tell, and let's assume that these are concrete width and height. We'll say the grids are 32 by 32, just for this example. Now we can already tell that neither of these is a multiple of 32 because 32 is a power of 2, and neither of these are a power of 2. So how do we get it so that this actually snaps to either this corner, it doesn't really matter. We just need it to snap to a corner, and then we can sort of jumble it around. Well, it's actually not that bad. In programming and mathematics, you have something called integer division. Integer division is basically saying something like, if I have 6 divided by 4, we're going to truncate that. Since 4 does not go into evenly to 6 more than one time, we're going to say that's 1. Now, we know in fact that this is actually 1.5, but we're just truncating and removing that part and just seeing how many times it goes evenly into that. We can use this to our advantage. Let's see, how many times does 32 go into 133? Well, we can say 133 divided by 32 equals 4, I think. My math might be wrong on that. And then we'll say, okay, how many times does 32 go into 67? Well, 67 divided by 32, that's 2. We get 2 pieces. Now, we can just multiply this result. So we know that we get 4, 2. But that's not the place that we want to place this, because that would be somewhere like right up here. So we have to get this back into 32 by 32 space. So to do that, we just multiply both of those by 32, and that gives us 128 by 64. And then that would actually be on one of these corners. So as you can see, getting it to snap to a grid is actually not that difficult. You literally just divide by your grid width, your grid height, then you multiply by that grid width and grid height. And make sure you're doing all this as integers, because if you do it as integers, then you will lose the floating point part, and that will give you one of these corners. So now that we know how to snap a mouse position on the screen to the grid, the last thing we have to do is figure out how to draw the grid. So the first thing we have to do is take into account the camera's position. So the camera will be positioned at some XY coordinate, right? And then we want to start drawing first this line, then we draw this line, then we draw this line, and we also want to draw this line, this line, this line. And so in order to do that, we need to figure out, okay, where's the first grid point from this XY? And to do that, we can actually do the same exact thing. We just say XY divided by 32 times 32, or whatever your width and height is. You would divide the X by the width and the Y by the height. And then this will give you some XY that is actually right here. And then you can say, okay, this is my first X, this is my first Y. And then what you do is you say, okay, draw from my first X, which would be right here, and then my first Y, draw a line from there to my first X to my first Y plus whatever the screen height is. So we'll say H. What that will do is draw a point from here. This is first X, first Y, right? Then we're still at X, and then Y plus H would bring us up to here. And then we can say, okay, also draw a line from my first X, my first Y, to my first X plus the screen width, my first Y. What that will do is it'll draw a line from here all the way to here. So then we'll get that line. Then how do we get the next line? Well, we say the next line is actually the first x plus the grid width, GW, times whatever line index we're currently on. The next y is y plus the grid height times whatever index we're on. And so what this means is, okay, so if we're doing this, this is the first line, we would get first x plus 32, which would bring us to here. And we would get first y plus 32, which would bring us to this point. And then we would do the same thing. We would say, okay, go from this y all the way to here, go from this x all the way up to here. And then we continue doing that. So that gets us each individual point. The last thing we have to figure out is how many of these lines do we need? And once again, this can be solved with integer division. So how many of the y lines do we need is what I'm going to call these the vertical lines. Well, we need as many vertical lines as can fit within this width. If we have width and we have grid width, we can say width over grid width equals the number of vertical lines. That will give us, so we can fit however many grid spaces fit into here, we can fit however many of those just by dividing width by grid width. And then same thing for the horizontal lines. We just do our height over our grid height, and that will give us the number of horizontal lines that we can fit into this grid. So that about covers it, because now we know exactly how many lines we need to draw. We know how to increment through as we're looping through each line we're drawing. And we know how to snap a position inside the grid to one of the specific corners. Now that we know how to do all that, let's actually implement it all and code it. Right before we begin to code, let's actually fix this real quick. I have a to-do in here, a couple to-dos. First of all, I'm going to change this to ×2 so that we get smaller sprites because those were huge. And then I'm also going to change the texture coordinates because actually the texture coordinates for the X were flipped when I was dragging and dropping items onto the screen. So if we just switch the X's from 2 here and 0 here, that should fix the flipping of your textures, right? And then we can take those to-dos out. Next thing I'm going to do is I'm going to create a constant class inside of util. And really this is more like just sort of a, let's call this settings. Okay, I'm going to call it settings because it's not really constant. It's just going to be variables that are easy for us to modify. So we're going to call this first one grid X equals, or actually grid width equals 32. And in my experience, if you're working with a grid, you usually want it to have the same width and height, but we're going to do this just because, why not? So they can change the grid width and the grid height dynamically, and that won't matter. Let's go and create one more class now. We'll go up to components. We're going to create a new class, and we're going to call this grid lines. This component will be in charge of drawing grid lines. Very simple. That's all it does. Now I'm going to say that this guy extends component, and we are going to say we only need one method, which is the update method. So we're going to override our update method, and this is where we're going to do all of the work. So we're going to need a couple of things. We're going to need our camera position, and we're also going to need our projection size. Now, what is the projection size? If you remember inside of our camera class, we have the projection matrix, and the projection matrix just tells our screen how big we would like it to be in pixels or in world units. So we have this concept of window width, which is completely different than projection width. Projection width is how big we would like our world units to be displayed in any window, and then depending on the window size does not matter. We will always know we have this many world units inside that window to be able to draw on. So that's our projection size. So let's actually go up here real quick, and we're just going to say, actually make this private. Private vector 2f projection size, and I'm just going to say this is a new vector 2f, and we're going to give it these properties right here actually. So I'll just copy that, paste it right there, and copy this one and paste it as our y. Then I'm going to change this to use that. So we'll say this is actually projection size, not projection matrix, .x, and this one is projection size, .y. Okay. Then we're going to create a little getter just so that we can get that. We'll say public vector 2f get projection size, return this dot projection size. All right, let's go back to grid lines. So now we can get the camera position, we can get the projection size, because those are the two things we will need to be able to calculate where exactly we should draw our first grid line. So we'll say the camera position is equal to the window.getScene.camera.position. And then we'll say our projection size is equal to the window.getScene.camera.getProjection size. Now we can calculate where our first X and our first Y are. We'll do this exactly how we said. We just divide by the grid width and we multiply by the grid width, the camera's position. So we'll say integer cast camera pose.x over constants.grid, not constants, sorry, settings.grid width times settings.grid height. Okay, and then first Y is literally the same thing just for Y. So we'll say first Y is camera pose.y over settings.grid height times settings.grid height. There we go. So this is exactly what we talked about. It's literally just going to snap it to one of those corners, which is perfect for our purposes. Now we want to figure out how many vertical lines we can have and how many horizontal lines we can have. I'm just going to truncate these to VT and HC. So vertical, horizontal. And this can be a little bit confusing. Just remember, vertical is up and down, horizontal is left and right. So how many up and down lines can we get? We need to focus on the X for that. And then for horizontal, we need to focus on the Y, which is why it's a little bit confusing. So the way we do this is we just say, we'll use the projection size.y. So what's the height we have over the settings.grid height. And that's how many horizontal lines we can fit. See, I'm already messing up. So this should be X. This should be width. That's how many of the vertical lines we can fit. We focus on X. And then for horizontal, we'll say this is projection size dot Y over settings dot grid height. Okay, there we go. So now we have the first X, we have the first Y, we have the number of vertical lines we can fit, and the number of horizontal lines that we can fit. Now I'm actually going to say height equals projection size dot Y and width equals projection size dot X, and we'll just cast those to integers. And you'll see why in a minute. I'm just going to do it like this for now. Ease of use. Then we're going to say for int I equals 0 until I is less than, well, okay. So typically we're going to have more vertical lines than we are horizontal lines, but I guess there's a possibility that could not be true. So we'll say int max lines equals number of vertical lines is greater than number of horizontal lines. If it is, it's vertical lines, otherwise it's horizontal lines. So basically we're just seeing which one's bigger. I guess we could just do a math.max, yeah. Okay, so we're just seeing which one of these is bigger, getting the bigger one for max lines. Then we'll say for int I equals 0 until I is less than max lines, I plus plus. And then what we can do is we can calculate where our X and Y are going to be, just like we talked about in the video. So we'll say first, so we'll say X equals first X plus the settings dot grid width times our current index. This is exactly the formula we talked about. And then we'll say int Y equals first Y plus our settings dot our grid height times I. So 0th, it'll be at the bottom left corner. First index, this will be 1 to the right, this will be 1 up, so on and so forth. Then we'll actually draw our lines. So we'll say if I is less than number of vertical lines, we will draw a vertical line. We'll say debug draw to add line 2D. So we want to make sure that we're drawing from the X's, so the X needs to stay the same since this is a vertical line, and the Y needs to go up. So we'll say we'll draw it from new vector 2F X Y to new vector 2F X, Y plus height. And then that should be good. And let's give it a color too. So I'm just going to go up here, say vector 3F color equals new vector 3F. And I'm going to say like 0.2F just to give it a little bit of a gray color. And then right here, we'll just say color. Then we'll say if I is less than number of horizontal lines, we will draw a horizontal line. Say debug draw to add line 2D. Since we're drawing a horizontal line, this time it's the X that's changing. The Y needs to stay the same. So we'll say new vector 2F X, Y, new vector 2F X plus width Y. And we'll give this the color too. Now, fingers crossed, this should actually draw the lines, but we don't have any way to do that yet because we're not actually updating this. So let's go into our level editor scene, and I'm going to go up to the top. And what I'm going to do is, instead of having mouse controls be a mouse controls object, I'm just going to say this is game object, and we're going to call this level editor stuff. Okay, horrible name, but we may change that in the future. This is basically just going to have all of our level editor components that we need, and we need to give it a name. We'll just call this level editor, a empty transform, and a 0th z index, okay? So that should be good. And then what we're going to do is inside of our init, we'll just say level editor stuff, add component, new mouse controls, and then level editor stuff, add component, new grid lines. This way we can just add components to this, and we know this will never be serialized because we're not actually adding it to our scene. And then we'll just say level editor stuff.update, and right here we'll just say level editor stuff.get component, mouse controls dot class dot pickup object. And we may change that in the future, but it's good enough. Okay, so you can see it's kind of working. I clearly made a mistake when we're drawing the lines because we're not supposed to use X and Y for our variables that are not changing. Let's go back to grid lines. I did X, Y here. This should actually be first X and first Y. And same thing down here. So first X and first Y. And then this should be first Y, and this should be first X. Okay, now if we run this again, that's definitely not the right thing either, but that's kind of cool. Okay, let's see if I can get this right this time. Okay, I finally got it. So this is X. This is first Y, this is X, should be first Y plus I. Okay, so you can see that the X does not change, and then the first Y goes from the bottom to the top of the screen, and then in this one, the Y does not change, and the X goes from the left side of the screen to the right side of the screen. So that is what we should actually be drawing. Now, if we run this, we get a grid, but you'll notice, if you can see my mouse in the left corner of the screen here, we're actually one off. And so the reason we're one off is just because when we're snapping, we're actually snapping to this corner. So to combat that, what we can do is say first X is actually this camera position over grid settings, all this stuff. And then what we're going to do is we're going to wrap this in parentheses. And then I'm going to take away this parenthesis over here. And then we're going to do the same thing right here. So what we're doing is we're actually moving these back one space so that we make sure to get all of them. Then we need to make sure that we're actually doing two more lines, because we're going back one, so we need one extra line on the bottom and left and one extra line on the top and the right. And then right here we'll say plus settings.grid width times 2 and plus settings.grid width times 2. And this one should actually be grid height. Okay, so this way we make sure that we get the appropriate width and height as well. And then if we rerun this one more time, there we go. You notice that this is fully covered all around, which is good. And if we were to move our camera, we would also get the same thing. One more thing I'm going to do now. Actually, we need to go into level editor scene anyway, so let's go level editor scene. And I changed this to times2. Actually, keep this times4 because I do like it for the I am GUI, but then when we're drawing it here, right here, let's not pass in sprite width. We'll pass in 32 by 32. That way we have the same width and height as our grid. That way when we drag something in, it actually fits inside of our grid size. Let's also stop drawing that line real quick because we know it works. No reason to keep drawing it. So I'm going to take this out and take all that out. Okay, now what we need to do is actually make it so that our objects snap to the grid, and this is actually really simple. If we go to our level editor controls or our mouse controls, right inside here, this is sort of where we're setting the X and the Y of our game object every single frame. So what we can do is we can just snap this to one of the corners, right? So what we'll say is holding object.transform.position.x equals holding object.transform.position.x over settings.grid width times settings.grid width. And let's actually wrap this in parentheses just so that we know we are doing this in a specific order for a reason. And what this should do is this should start snapping its X position. It won't snap its Y position yet, but if we go here, it's actually not doing anything. And that's because we need to cast this to an integer. So make sure to cast that to an integer. And I'm going to go ahead and just copy this, paste it, and then we'll do the same thing for the Y. We'll just say this is Y, this is Y, this is grid height, and this is grid height. There we go. And now if we run this, and we click on an object, you can see as I move the mouse, it tracks to whichever grid position my mouse is in. This is really cool. This is like the beginning of some true level editor-y type stuff. We can actually sort of drag things in and start building a little level. And then we can drag some of these blocks up and everything, and it's all good. Now, there's a couple problems. First of all, one thing I'm going to do is side of our level editor scene, I'm going to get rid of those two giant squares because we know our alpha blending is working properly now. I'm just going to comment that out just in case we ever need to bring it back again. Then I'm going to delete that level file that we had. So I'm just going to delete level.txt. That way we get a fresh level. And the problem that I'm mentioning is basically if you drag in a bunch of stuff and just keep dragging stuff in, what you'll notice is if I exit and I re-enter, no, it actually worked this time. Let's keep dragging more stuff in. Well, I would if I could. Okay, that's a weird bug. So I was dragging stuff in, but it wasn't showing up. So that's another bug we have to fix. But also, if I just keep bringing stuff in, you'll notice that sometimes it doesn't save properly. And I haven't quite figured out what that bug is yet, but it's something I have to look into and that we have to fix because that's definitely not good. So let's see if it does it this time. Yeah, so see how this square is missing even though I filled it in? That's not good. What I'm guessing is there's something weird going on with when we're adding game objects and they don't get added completely to our list and it just doesn't serialize it for some reason. So we've got to fix that. But once we fix that, we have a level editor that we can drag and drop stuff into. Our next thing that we have to do is to have a button down here that says add component, where we can either add a component or we'll just update our prefabs object. I'm not sure which direction I'm going to go yet, but that way we can start doing our physics because then we can start bringing in objects with physics components and start building levels and testing to see if everything is working properly. In order to do that, though, we need a player controller to see if we can control a player. So we might actually go into animations, possibly, or physics. Let me know which one you guys would rather go into. So a finite state machine-based animation system or starting physics. And then we will start to do that next tutorial. I hope you guys enjoyed this. If you did, please hit like and subscribe, and I'll see you guys in the next tutorial.